to incorporate it into his magnificent work, the Principia. But even then, it would take a couple of hundred years, and William Hamilton, to see the scope and versatility of the vector. In his attempt to find a mathematical way to interpret rotation in space in physical terms, Hamilton sought a three-dimensional analog of complex numbers. Instead, he found an algebra of four-dimensional objects, which he called quaternions. A quaternion has a vector part, which is three-dimensional, and a one-dimensional scalar part. Though it would take a bit of modern refinement in the vector and the scalar, William Hamilton had devised an enormously valuable mode of expressing Newton's mechanics. James Clerk Maxwell, a pioneer in electricity and magnetism, saw the theoretical brilliance of Hamilton's ideas, but even so, they weren't generally accepted. To be effective, content and form have to work together. And while Hamilton's theory was simply brilliant, its form was too complicated to survive. In essence, however, the theory did survive. In the 19th century, a professor at Yale, Josiah Willard Gibbs, took original ideas from Hamilton and Grossman and applied them to theoretical physics. However, reluctant to take credit for ideas that weren't his to begin with, Gibbs waited 2 decades before permitting E.B. Wilson to reconstruct his notes into book form. Finally, with publication in 1901, vectors sailed around the globe, until, like the sound of music, vectors could be heard from just about everywhere there's a meeting of the minds.
9 bottles of beer, if one of those bottles should happen to fall.
Of course, vector algebra, like music notation, takes some practice. And even aboard the Irish coffee, a little exercise couldn't make the situation much worse. And in any case, vectors, unlike the lyrics of certain songs, are quite versatile.
A vector can be multiplied by another vector. The dot product of A and B is a scalar that measures the tendency of the two vectors to point in the same direction. A dot B is equal to the length of A times the length of B times the cosine of the angle between them. If A and B are perpendicular, their dot product is 0. And the dot product of a vector with itself is just the square of its length.
38 bottles of beer on the wall.